All right, so let's look at paper 2, question number 10. Before we discuss the question, let's make sure that we all of us know one basic concept. What is it? Let's say you got a clay, the clay you used to play. Let's say the clay, what you got looks like this. And let's say the amount of clay is 50 cubic centimeters. And let's say you're going to play something. So what do? You take this clay and roll it and turn to a shape like this. Let's say you turn to this shape, like you roll it, and I'm sure you would have played such games when you were a kid. So you turned into something like this. Let's say in this process, while turning this bowl, the clay bowl into a cylinder, there was no any wastage. That means, let's say none of the clay got stick into your hand or to the ground, none. Without any wastage, you could convert the clay ball into a clay cylinder. Now the question is, what's the amount of clay that's there in this cylinder? What's the amount of clay? Obvious, it should be the clay you had. What's the amount of clay you had? 50. So still it should be 50. All right. So what am I trying to say here? The, the, the message I'm trying to pass to you guys is just because the shape changes, the amount of material doesn't change. There was 50 cubic centimeter of clay, and still there is 50 cubic centimeter of clay. But mind you, that happens only if there's no wastage. But if there was any wastage, then it won't be 50, it'll be less. But I told you there's no wastage. If there's no wastage, when it was a ball, if it was 50 cubic centimeter of clay, and once you turn it to a cylinder, still there'll be 50 cubic centimeter of clay. Hope you all understood. Right. So bearing this basic concept in our mind, let's look at the question that has been given to us. A metal right triangular prism which had a cross-sectional area of 20 square centimeters and height and a length of 8 centimeters was melted. Using all the metal obtained by melting the prism, certain number of identical spheres with radius r centimeters were made without any wastage. All right. So that changed the shape. So the moment you hear there's no wastage, the moment you read there's no wastage, without any wastage, what should come into your mind? The amount of material. So what's the material here? It's metal. So the amount of metal will be the same. So what is it? Volume of metal in prism, or volume of metal while it was a prism, volume of metal in prism is equal to what? The new thing that has been made using the metal. What is it? Spheres. So volume of metal used to make spheres. Since there's no wastage, I can write this. The entire prism's metal was getting converted or is getting used to make the spheres. So volume of metal used to make spheres. All right. So now, how do we find the volume of metal in prism, or the amount of metal that was there when the prism was there. So what is it? How do you find the volume of a prism? What's the formula? Area of the cross section times multiplied by the length. Any prism, this is the formula. What is it? The formula to find the volume of a prism is area of the cross section into length. All right, equals. What's the volume of metal used to make spheres? So spheres, it's plural tense. So how do you find the volume of metal used to make spheres? That is volume of one sphere, volume of one sphere multiplied by number of spheres made. Because it's volume of spheres. So how do you find the volume of spheres? Volume of one sphere into number of spheres. All right. So now just a matter of plugging the values. So do we know the area of the cross section? What was the area of the cross section? Why are we using the plural tense? Rather not plural tense, the past tense, because the prism is no more. It got melted. So what was the area of the cross section? It was 20. So 20 times. What's the length? Length is h equals. How do you find the volume of one sphere? What's the formula? That's 4 over 3 pi r cube times. What's the number of spheres? Have they told us what the number of spheres is? Yes, that's n. If the total number of spheres made is n, so that's n. All right. So we have 20 times h, which can be written as 20h equals 4 over 3 pi. Let's look at the radius. R, the radius. Have they given us the radius? Certain number of identical spheres with radius r. So what's the radius? It's r. So in the place of radius, you put r to the power 3. So in this question, they have given the radius as r. But in another question, they could give you as x or y or any letter they wish. So in the place of radius, you got to look what letter they have given. Accordingly, you got to substitute. All right. Times n. All right. And now what are we supposed to prove? We are supposed to show that n is equal to something, which means we got to isolate n. We got to make n the subject. So let's put everything else to the other side. So how do we put the things to the other side? We already got 20h in the left. So let's start with bringing the division 3. So when division 3 goes other side, what does it become? It becomes multiplication 3. And now we'll bring the multiplication 4 pi r cube to the other side. So when multiplication goes other side, what does it become? It becomes division. Division what? 4 pi r cube. And what's remaining in the right now? It's n. All right, so now we'll cancel. 4 has 1 4 and 20 has 5. All right, that's it with canceling. Now it's time to multiply. So when we multiply, We have 5h times 3. What would that give us? 15h. And what's going to be the denominator? We got pi r cube equals what? Equals to n. And let's check whether examiner is happy with what we have presented. He has asked us to prove n is equal to 15h over pi r cube, and we have proved it. N is equal to 15h over pi r cube. Let's make it a bit more beautiful. Normally, we present an equation leaving the subject in the left. So let's write the same thing as n equals. There's, there's no maths here, just a matter of copying the same thing, but putting the keeping writing the n in the left and the rest in the right. 15h over pi r cube. All right. So that's with the first part of the question. All right. So let's look at the part B of the question. What is said here? Substitute the values. N equals 24, h equals 954.3 centimeters, and pi equals 3.14 to the above equation. Which equation? The equation what we got as the answer for the part A. So by using the logarithmic tables, calculate the value of r correct to 1 decimal place. All right. So let's write the equation first. What is it? We have got in part A, n equals 15 times h divided by pi r cube. All right. And what's told to us? We have been told n is 24. So 24 equals 15 times, what's the h? 954.3 divided by, what's pi? 3.14 times r. That's what we are supposed to find. So r cube. All right. So before we use the log table, we have to make r the subject. We got to find out what is r equal to. So what's the problem here? The letter that we are supposed to find out is in the denominator. So what can we do? Let's get it to the numerator. How can we get it? Let's put him to the other side. So let's see how it works. So when we put our cube to the other side, what would it be? 24 division r cube goes other side. What would it become? It's going to be multiplication r cube. So what's in the right now? 15 times 954.3 divided by 3.14. So r cube equals, let's put the 24 to the other side. So 15 times 954.3 and multiplication 24 goes other side, division 24. All right, so we found out what's r cube is. So how do we find out what's r is? So r is equal to what? Let's put the cube. This is cube here, r cube. So let's put the cube to the other side. So when the cube goes other side, it becomes the inverse of cube. What's the inverse of cube? when it comes this side, becomes inverse of cube. So it's going to be cubic root. So we put the root sign and cubic root. So what does that mean? You got to put 3 here. So this is what r is equal to. Now, how do we figure out the r's value? We'll have to use the logarithmic tables. All right, let's see how to use it. All right, so how to use the logarithmic table? So before we use the logarithmic tables, let's write the root in index form. How can we write that in index form? 15 times 954.3 over 24. How can we write cubic root in index form? What does cubic root mean in index form? It's 1 over 3. So r is equal to, instead of putting the cubic root sign, we can write the same thing as what? The entire thing to the power 1 over 3. Cubic root is 1 over 3. And what would, just an additional question, what would square root be? Example, what does square root of x mean? It can be written as what? X to the power 1 over 2. What does cubic root of x mean? That means x to the power 1 over 3. All right. So now we can apply log. So what do? We introduce log to the r, or to the left-hand side. So log r. If you introduce something new to the left, you got to introduce the same new thing to the right too. So you put log, or you can simply write lg because we put base 10. So log to the base 10. So you can also write it as lg. That would be better. So lg 15 times 954.3 over 24 to the power 1 over 3. So let the log bar will keep on continuing, but to save time, I'm not writing it. You don't have to write it. Let's concentrate only on the right-hand side now. So what's the first thing that can be done? This power can be brought front. It can be written as what? 1 over 3 log 15 times 954.3 over 24. All right. And what's the next thing we got to do? It's time to apply the logarithmic rules. So what is it? 1/3. Now, what do? We convert the multiplication to it becomes an addition, and division becomes a subtraction. So 1 over 3 times log 15, then there's a multiplication, put addition, log 954.3 minus log 24. So that's 1 over 3 times, what's log 15? So you got to use the log table. But before you use the log table, you have to decide what's going to be the characteristic. The mantissa can be found out using the log table, but the characteristic should be decided before you go to the log table. So what's meant by the characteristic? What should come to the yellow blank here? Log 15. There are many ways to figure out what's going to come. One way is, where is 15th decimal point? Decimal point is not to be seen. What does that mean? 15 means 15 point. The decimal point is at the end when the decimal point is not to be seen. All right. So now how do you decide the characteristic or what should come to the yellow blank? See, before the decimal point, how many digits are there? That's 1, 2. So then what would you write in the yellow blank? There are 2 digits, then you reduce, you less 1. So when you reduce 1 from 2, what do you get? 1. So you write 1 in the characteristic. How did 1 come here? There are 2 digits before the decimal point. Then when you're writing here, what do? You reduce 1 from that 2. So if you reduce 1 from 2, it's 1. That's the reason I put 1 in the characteristic. That's one way of thinking. Or as another way of thinking is 15 means 15 point. The ones who are familiar with scientific notation or standard form, how can I write this 15 point in standard form? It's 1.5 times 10 to the power 1. See what we get here? It's 1. So we write that 1 in the characteristic. So you can think in either of these ways to decide what should be the characteristic. How do you decide what's going to be the mantissa? For that, you'll have to use the log table. Let's see how to use it. All right, so here the log table is, so log 15. What does 15 mean? 15.0. So what you got to do is, you got to check what's the number in the 15th row, 0th column. So 15th row, 0th column, what is it? 1761. So what would be the mantissa? 1761. All right. So what's log 15? 1.1761. All right. Now we got to calculate what's log 954.3 is. So before we use the log tables, we have to decide what's going to be the characteristic. And so how do we decide what's going to be the characteristic? 954.3. There are 2 ways of thinking. One is you count how many digits are there before the decimal point. That's 1, 2, 3. So there are 3 digits. Then what would you put in the yellow blank? 2. 1 less than 3 is 2. That's one way of thinking. Or as if you know scientific notation or standard form, how can you write this in scientific notation? 9.543 times 10 to the power 2. So you see 2 here, then that becomes the characteristic. All right. All right. To decide the mantissa, we got to look at the log table. 95th row, 4th column. What's then the 95th row, 4th column? That's 9795. So it's 9795, but we cannot go with that. There's a 3 here. What does that mean? We have to go to the mean difference table, and while being in the same row, be in the 95th row, and see what's there in the 3rd column in the mean difference table. That's 1. So you got to get that 1 and add it to this. So then it's 9796. So what's going to be the mantissa? 9796 minus log 24. So you have to decide what's going to be the characteristic. So just like earlier, it's going to be 1 point something. How would you get the Mantis part? You got to use the log tables. See what's there in the 24th row, which column 24 means 24.0. So see what's there in the 24th row, 0th column in your log tables. So what do you get? 24th row, 0th column, you would have got 3802. All right, so we found all the log values. So now we have 1/3 of what? Okay, so do the addition and then subtract 1.1761 plus 2.9796. Get the addition, then do the subtraction and see what you get. So what do you get when you add and subtract? You would have got 2.7755. So you got to find out what's 1/3 of 2.7755. So how do we find what's 1/3 of 2.7755 is? So 1 times 2.7755 gives the same thing, 2.7755 divided by 3. All right, so you can use the long division. You can divide 2.7755 by 3 and get the answer for the division. So what is it going to be? You can do the long division and get the answer. All right, so when you did the long division, when you do the long division, how many decimal places should you find out? You got to find out, or you got to work for 5 decimal places. And when you're writing the answer, write it correct to 4 decimal places. So 0.925. Before you write 1, see what's next to it. What's next to it? That is 6. So 6 is bigger than 5. Then what do you do? When you round it to 4 decimal places, you got to add 1 to 1. Why is that? Because the next digit is something bigger than 5. If it's 5 or bigger than 5, you add 1. So that's the way to round a 5 decimal place number to a 4 decimal place number. So it's 0.9252. So remember, what's this? This is log R. Can you remember in the left-hand side, we wrote a log. So it's log R equals 0.9252. So what's our goal now? Finding out what's R is. So how do we find out what's R? R equals log goes to the other side. When log goes to other side, it becomes the inverse of log. What do we call the inverse of log as? We call it as anti-log. Anti-log 0.9252. So R equals, there are multiple ways, like you would have got used to different, I will be showing a particular way, but if you're not used to that way, you can use your own way when it comes to finding anti-log. So when you see 0 here, I put what? Times 10 to the power 0. If I see 1, I would have put times 10 to the power 1. So now I got to locate the, the location of 9252 in the log table. Where is 9252 living in the log table? Let's get the log table once again. So I'm hunting for 9252, but 9252 isn't there. 9248 is there. So I'll take that. So where is 9248? That's in the 84th row. And which column? In the first column. So the 984, 1. Look, if you have to look, if you need the column number, you look up. All right. So let's record it. 84th row and 924, it is in the column number 1. Look up. In your logarithmic tables, look up, then you will see it's in the first column, number 1, column number 1. But there's a problem. What's the problem? What I needed was 9252. What I got was 9248. How much more to get? Let's subtract and see. 9252 is what I need, but what I got is 9248. So how much more is needed? I need 4 more. Right. So from where do I get that 4? I get it from the mean difference table. There is 4 in the mean difference table here. So in which column is it? In the mean difference table, look up, look at your log tables, you will see 7. And where do you place the decimal point? As per this method, as per the method I use, always after 1 digit. So 8.417, right? So then R is equal to, what do you see here? 8.417 times 10 to the power 0. So you don't shift the decimal point. If it was like 10 to the power 1, then I would have shifted the decimal point once to the right and written the answer as 84.17. But here, since it's 10 to the power 0, there's no shifting. The answer is going to be still the same, 8.417. Got it? But there are multiple methods, or like there's no any strict method. Like what I'm trying to say is, uh, depends. Some people use this method, some others have their own methods when it comes to finding an entire log. You can stick to your own method, all right? But as per my method, you write the location of the number, then you always place the decimal point after 1 digit. So 8, that's 1 digit. After that, I place the decimal point, and now I should decide how many times decimal point should get shifted. How do I decide it? Look what is here. If it's 10 to the power 0, no shifting. If it's 10 to the power 2, I will shift the decimal point twice to the right. Got it? So what's the final answer? 8.417. But wait, before we present that as the final answer, let's read the question once again. Maybe they need the answer correct to some number of decimal places. All right. So here they have said they need the value of R correct to 1 decimal place. So then we say what? R equals 8 point. Before we write 4, the first decimal place, see what's next to it. That's 1. 1 is less than 5. So when you round into 1 decimal place, you just write the 4 as it is. Why? The digit next to it, it is less than 5. Then you can write 4 as it is. So R equals 8.4. Within brackets, you can say correct to 1 dp. Correct to 1 dp, decimal place. All right, so we have found the R's value using the logarithmic tables.